Hi fellas, this is Chemaddicts again to the solution. Welcome back to my another video tutorial. Well fellas, today we're gonna study the reaction between iodine and propanone. So we're gonna investigate the reaction. We're gonna investigate the reaction between iodine and propanone in acidic conditions. So let's get started. So the question says, a student investigated the reaction between iodine and propanone in acidic conditions. So this is the chemical reaction given. The chemical equation is given over here. So let us look at the details that are given here. 50 cm cube of 0.02 mole per dm cube of iodine solution was measured into a flask. So 25 cm cube of propanone and 25 cm cube of 1 mole per dm cube sulfuric acid were measured into a second flask. So we have taken iodine solution in a flask and in one flask, and we have taken propanone and sulfuric acid mixture in another flask, that is in second flask. Okay, they are separated. Initially they were separated. Okay, so let's move on. Several 10 cm cube samples of 0.5 mole per dm cube sodium hydrogen carbonate solution were placed in separate conical flasks. Okay, so we have taken many we have taken several separate conical flasks. We have taken separate conical flasks. Okay, several separate conical flasks, which is empty. Okay, and we have taken 10 cm cube of sample of 0.5 mole per dm cube of sodium hydrogen carbonate and pour it in separate conical flasks. So there are sodium hydrogen carbonate in separate conical flasks. Okay, so the mixture of propanone and sulfuric acid was added to the iodine, and the cloak started. So we have the mixture of propanone and sulfuric acid added to the iodine. We have added the previous mixture, and a cloak reaction started, and a cloak started, and we have started the clock. Okay, so at 2-minute intervals, 10 cm cube of the reaction mixture was removed and added to one of the flasks containing sodium hydrogen carbonate solution. So at the time intervals, we have taken the reaction mixture from the propanone, sulfuric acid, and iodine, mixture containing propanone, sulfuric acid, and iodine, and we have added one of the flasks containing a sodium hydrogen carbonate solution. So we have added this mixture. To the flask containing sodium hydrogen carbonate. So at intervals, we have added this mixture to the sodium hydrogen carbonate solution. Okay, which is in several conical flasks. Okay, the contents of these flasks were then titrated. Then later on, we have titrated this sample with sodium thiosulfate. So finally we are going to titrate those samples, number of samples with sodium thiosulfate. So there are many samples. Okay, several samples, and we are going to carry out several titration. Okay, so I hope that you have understood the experiment scenario. Okay, so let us look at the question that is asked here. Okay, so the first question is, explain why the purpose of adding this reaction mixture to the sodium hydrogen carbonate solution. So why should we add sodium hydrogen carbonate to the reaction mixture? Which reaction mixture? It is the mixture of propanone sulfuric acid with iodine. So why? So before answering why, we need to know the name of the method that is used here. This is called quenching method. Okay, so this is This is called quenching method. Quenching. So this method is called quenching. Okay. So quenching the reaction. This is called the quenching the reaction. So basically what we are doing here, we are stopping the reaction at time intervals. Okay, we are dipping the solution and stop the reaction at regular time intervals. Okay, so that's what we are doing here. So as you can see here, that the total mark for this question is 2. So what they have asked, asked to explain the purpose. So they wanted the reason for adding sodium hydrogen carbonate. Okay, so there should be, as you can see, that there should be 2 reasons. Okay, so there should be 2 reasons for 2 marks. So each mark will have 1 reason, so 1 reason per mark. Okay, so let us look at the first reason. So the first reason is to quench the reaction completely. To quench the reaction completely. Okay, so this is the reason number 1. Reason 1. Okay, to quench the reaction completely. Okay, so we are going to quench the reaction completely. That's why. In other word, we can say freeze. This is also this quenching also means freeze. Freeze. Okay, freeze. You can say in other way around, like freeze, then stop, stopping, freezing, freezing the reaction, stopping the reaction. Anything else can do that, which means stopping the reaction. Okay, and prevent and prevent and prevent iodine to react completely, and prevent iodine to react completely. The other reason is preventing, well, the reason for quenching the reaction completely, the reason for quenching the reaction completely is to prevent iodine to react completely. Okay, so here the other reason is for quenching the reaction is the reaction of this, the rate of reaction of this is pretty fast. Okay, the rate is pretty fast over here, and we are investigating the rate of this reaction. So as we are following the rate of this reaction, so the reaction should be very slow, so we can follow the reaction. So that is why we are quenching the reaction completely. Okay, and as you can see that if we prevent iodine reacting with propanone, okay, then the reaction would be slower. So the way is to make the reaction slow is to prevent this iodine to react with this propanone. So there should be a way that we can prevent this reaction. So by the time it has reacted before quenching, okay, so we should quench the reaction, and by this meantime small amount of iodine would have reacted with this propanone. Okay, so by this process we can calculate the rate. So this is how we're gonna do. Okay, so the reason for this is to prevent iodine from reacting, further iodine from reacting. So we are limiting the iodine over here. Okay, so we are limiting the iodine over here, so we will prevent further iodine from reacting. Okay, so react completely, further iodine from reacting completely, further iodine to react completely. Okay, so the another reason is for this is the reason number 2, which is by neutralizing the acid or removing the acid. Okay, the reason for this question is the second reason for this question is by neutralizing the acid or removing the acid. So as you can see that in here, uh, this acidic condition means that the H plus ion should involve here. So in here, H plus ion is acting as a catalyst for this particular reaction. So if we stop this H plus ion involving in this reaction, so the reaction won't happen. So no further change of iodine would occur. So therefore, if we remove this H plus ion from this reaction, so no further change in iodine would occur. Okay, so that the acid does not react with the sodium thiosulfate. So after doing this, if we titrate this with uh, sodium thiosulfate, this H plus ion won't get involved with this sodium thiosulfate in the titration. If we use sodium hydrogen carbonate to remove this H plus ion. Okay, so if we remove this H plus ion, this won't get involved in the titration, which would react with this sodium thiosulfate solution. So here is the other another reason for this, for neutralizing this acid. Okay, so this is the solution for this first question. Okay, so let us move on to the second question. The question asked what indicator should be used in the titration. So they have asked us about the indicator that we should use for this titration. So why should we use indicator for this titration? That's because to detect the endpoint. That's the main motive for using indicator. Okay, so here we would use starch solution. Okay, so here the question arises once again that why should we use starch. So as you can see that it can detect the presence of iodine. If small amount of iodine is present in the reaction, it would give a significant change in color. It would give a significant color change. Okay, so that's why we are using starch solution. So let me write the reasons for using starch over here. Okay, so for the presence of iodine. Okay, so we are using starch solution to detect the presence of iodine. Okay, the second reason should be it changes color to blue. Okay, it changes color blue. It changes the solution color of the solution to blue. Okay, color of the solution to blue. For small presence of iodine, we will get significant color change. So for small presence of iodine, we will get significant color change. So here are the reason for this question, for this particular question. So why we are using starch as an indicator? There are lots of indicators in the market. So why we choosing particularly this starch? Why we are choosing this particular starch? We can use methyl orange, any other besides starch. So here is the reason. Since we are carrying out the titration of iodine thiosulfate in this experiment, we're gonna use starch solution. Why we are using starch solution? That's because to detect the presence of iodine. Okay, since it changes the color of the solution to blue complex. Okay, so here is the third reason. For small presence of iodine, it can detect a small presence of iodine. Okay, it can detect the small presence of iodine, and we will get significant color change. For small presence of iodine, we will get significant color change. Okay. Well, fellas, that's the end of this tutorial. So in the next tutorial, we're gonna discuss about C. Okay, we are going to discuss the next question in the next tutorial. Since the tutorial is getting bigger, so that's why we are going to discuss the next tutorial about the next question. Okay, we are going to discuss the next question in the next video.